Hi there guys, this is a short video, training video to show you an easy way to do multiple outlet duty point calculations. When I say multiple outlets, for argument's sake, a office complex where you would have 3 or 4 ablution blocks in the whole premises, a couple of garden taps, maybe a canteen on the premises, or a apartment block where you might have 20 or 30 apartments in a block, and you'll obviously have a variation in flow rate and a variation in your pressure on the system, and you need to actually do a duty point calculation to be able to do a selection on a pump. So the way I do it, and this is something that I'll post my email address in the description. Send me an email, I'll send you this raw Excel spreadsheet. It's formula based and it works in metric, by the way, so you'll see at the bottom here it gives you a duty point once it's done all the calculations in cubic meters per hour, and it works on meters total dynamic head. So you can basically just take those two answers that the system will generate for you and convert those to gallons per minute with simple formulas, or feet, depending on whether you're working on metric or imperial. So let me just show you how this little system works. It's actually very nifty. Okay, before I carry on, I just want you to understand the difference between a normal toilet cistern and a toilet flush master. I don't know that every country in the world uses a flush master, but or that they call it a flush master, but what it is actually, you would find in industrial complexes, industrial applications like office parks, for argument's sake, new installations. Flush master is a device where you would basically stand in front of a urinal, or you'd stand or a normal toilet that you would get at common airports, and you would push the button and this thing dumps an immense amount of water very quickly. Normally makes a big noise, so you know what I'm talking about. What it does, though, that's very different to a normal toilet cistern, is that it refills the void of potential water to do the next flush. It does it very quickly. Why? For argument's sake, if you were at a high traffic area like an airport toilet, for argument's sake, or a sports complex, let's say, for argument's sake, you've got 400 guys all standing half time waiting to use the toilet, and you can't have people using normal cistern style toilets where when you flush the toilet it takes up to 25 to 35 or 45 seconds to refill the toilet. It would take you forever to get through 400 people. So this device was then designed, it flushes, it instantly dumps up to 11, 12, 13 liters of water, and within 5 or 6 seconds it's refilled, so that the next person doesn't have to stand and wait for water to be able to do a flush, if you understand the concept. Whereas a toilet cistern, what that does is it normally works on a float ball valve system. It's your common domestic toilet. You're sitting on a bowl. Behind you is a stored capacity of water in a cistern. You would pull the valve and the valve plug would open and dump between 7 and maybe 12 liters of water. Now, the fact that you've dumped 12 liters of water in a toilet cistern is irrelevant. What's relevant is the refill rate of that cistern. And that's what we're trying to determine here. It might take 25 seconds to fill 11 liters of water in a normal toilet cistern. So the refill rate is, if you work it out, 11 liters in 25 seconds. That gives you a flow rate, which is considerably less than 11 liters of water in 4 seconds. Just do the calculation, you'll see how vastly different those two figures are. So what the spreadsheet does is it actually does that calculation for you. So for argument's sake, let's just see the difference here. Toilet cistern, normal, we work on 0.75 units, and if I say on this installation there's only one toilet, and you go down to the capacity here, you will see it works out a calculated flow rate of 0.3 cubic meters per hour. Now, it doesn't mean it's going to pump 300 liters in an hour. What it's saying is it pumps it at the rate of 300 liters an hour. In other words, if you left this toilet cistern to run for an hour, it would disperse 300 liters. But that's not what's happening. It might only do it for 25 seconds, but it does it at the flow rate of 0.3 cubes per hour, just to understand the difference. So let's just make that naught and change the toilet flush master and put in 1 there and see what the result is. You see how vastly different the two flow rates are. Toilet flush master is going to use 3.4 cubes an hour. which is considerably more. So understand the difference and make sure you know the difference, because you can really come unstuck on duty points and flow rates if you don't get those two numbers right. So when you're assessing a complex, make sure to know whether you're dealing with flush masters or cisterns. So let's do an example here now on this calculator. And what we're obviously trying to determine is the duty point to do the pump selection or the pump set selection. So the input of information that we're going to put between the head calculator and the flow rate calculator is that we want to get a duty point. All right? I'm sure this is why you're looking at the video in the first place. All right, so let's assume that we're on an office complex, okay? And on this office complex, we have all flush masters, and in total there are 16 flush masters on the premises. Now, 16 basin taps, these are hand wash basins. Just take into consideration that normally people would use either the cold or the hot water if it's two separate taps, or if you're in a mixer style, which is normally the case in a new office complex, it would be a combination of both. So the calculation that's done here on these basin taps is actually as if it is a mixer. In other words, it's using both hot and cold water. So the unit that we use for that is 9, and let's say mixer style basins for all these 16 flush masters in an ablution block is only 8, and we don't have any showers, we don't have any baths because it's an office complex, but we do have a hot water source. Now the calculation that we work on is the toilet basin taps. Every 5 toilet basin taps would be the same consumption as the refill rate on a 150 litre geyser. So in this case here, we almost have 10 basin taps. So to be conservative, I'm going to put in the fact that we have 250 litre geysers, and we don't have washing machines, but yes, we do have a dishwasher. Why? Because we have a little canteen on the premises, and they wash the dishes for this canteen. So be sure to know the difference between a domestic type dishwasher, which this one calculates on, or whether it's an industrial dishwasher. If it was an industrial dishwasher, this figure would be 3 times as many. So if you have one industrial dishwasher on site, you would actually put in 3, okay, to give you a higher flow rate. And let's say this office complex has 6 or 7 taps out in the gardens. One they're using to wash cars, the other they're using to just water the gardens, or clean paving, whatever the case is. So we go around the complex and we see, yes, they have 6 of these garden taps around the area. So we would put in that information. So this is now all the items that are possibly on site, and these are the quantities that we've determined are on site. So now we go down and we say, well, all those amenities would consume at peak 14 cubes per hour, 14.3 cubes per hour. Now you have to understand at different times of the day. For argument's sake, in the mornings, when everybody's arriving, everybody's making coffee, the canteen is fairly busy, the flow rate over a period of time, let's say between 6:30 in the morning and 8:15 in the morning, the flow rates would be higher. This calculator has taken that into account, and that would be the peak demand that you would need to do your pump selection. Now what it means is, if during 11 o'clock in the morning everybody's hard at work, as they normally are, the water consumption would drop considerably. Why? Because everybody's at their desks, nobody's at the toilets, the canteen's not busy, it might only get busy from 12 o'clock again. So your flow rate there might only be, when anybody does go to the toilet, you might be down as low as 2 or 3 cubes an hour. So, but I'll explain to you how we compensate for those variations in flow rate. This flow rate that it's giving you is for the peak demand. Might be mornings, and it might be late afternoons when everybody's ready to leave. Okay. So what we've basically done now is we've done the flow rate calculator, we've put in the amenities that are on the property. Now we need to determine the total head calculation. All right. If these were numbers that we were putting in for an apartment block, we would put in one of each, because they are basically the same, right? Let's say you've got an apartment block with 20 apartments in it. They all have one toilet, they all have one hand basin, they all have one bath, one shower, and you would just put in 1, 1, 1, 1, 1, and you would then at this point in here put in however many apartments there were, let's say 20. But in this demo, we are actually talking about an office complex, and we're talking about one office complex. So we've totally calculated how many items are on site or how many amenities are on site, and that's why we would leave that figure at 1. Right. Let's assume this is a 3-story building. Now, a 3-story building effectively is only 10 feet or 9 meters, maximum 10, but the system is calculated 11.25. Why is that? Because it has added additional percentage of friction loss through the fittings to get to the top of a 3-story building. So that's why the head at the moment is sitting at 11.25. And then I'll show you how it adds up. We know that at any one outlet, let's say the toilet outlet itself, the hand basin outlets in this office complex, the taps that you have in the canteen, at the kitchen, ideally we'd like between 2.5 and 3 bar at the taps. So this is the pressure that we're going to put in there, the required pressure in meters. So let's work on 3 bar, which if you do the conversion is 30 meters. This calculator is working in meters, so we have to put in the meters there. So now remember we said 3-story building should be between 9 and 10 meters plus the 30, but the answer it comes out with is 48.8 meters in total. Why? Because that required pressure, it has also added a safety factor and a percentage additionally to the 30 meters required, and that's why if you add those two totals up plus the safety factor, it comes to 48.8. All right, we don't have any sunken floors. Sunken floors are things like basements, and in office complexes that I've been to, mostly the only water source that you have in a basement is normally the fire suppression system, and this calculator is not working out your fire suppression, obviously. That's a completely separate calculator. So we're not going to put in any sunken floors there, but one thing we have to take into account is the mainline friction. All right, I've left it white there just to show you that it is a different number. This has to be calculated. Now that calculation, you can only do the calculation once you know what your flow rate is, your peak flow rate is. So how would we do that? And let me just explain what I mean by mainline friction. Mainline friction is the friction between the pump system, the pump set or the pump itself, whether it's 1 or 2 or 3, whatever pumps you're going to do, but you have a pump system. The point between that pump system and the actual building where the pipe network gets divided up into the different floors and goes off into a complete reticulation network. That pipe between the pump and the building is what we refer to as the mainline friction or the main line itself. Now to do that calculation, we would go to a very handy website, and you can copy that website and use it in future. If you copy it exactly as it is here, when you open it, it would open this section of the toolbox, and if you just go to the website itself without the toolbox, you'll see there are some fantastic calculators and stuff in this entire website. So what I've done here now is I just normally load up because I'm trying to calculate my pipe friction loss, and what it says is it is working on the internal diameter of the pipe. Okay, so if we go back to the document, we saw our flow rate was 14.3. So that's the figure that we're going to put in there, 14.3 cubes per hour. And let's assume that the mainline pipe work from the booster set or the pump system to the building is a 50 millimeter galvanized pipe. It would have an ID of about 44 millimeters. You can check those specifications on whatever pipe you're using, but the point is that whatever dimension you're going to work on, it must be the internal diameter. All right, and now let's assume that the length of pipe, this pump station on an office complex, what you'd usually find is that they'll tuck the pump station with the storage tanks or the water supply. They'll tuck it there far at the back of the building, out of the way, out of sight, for two reasons. One, aesthetically you want the building to look nice, and two, you don't want the noise of the pump system at the reception area, so they usually find a spot as far away from the traffic as possible, certainly from the reception area. So we then measure the total run of pipe from where this pump station is to where the pipe enters the building, and let's say we work on 65 meters. And it's what's handy about this calculator is that it gives you the different options of materials, pipe materials. So we would have high density polyethylene, low density polyethylene, UPVC, rubber lined. Now between galvanized and copper pipe, we would work on new steel. If it was an old building with galvanized pipe, we would talk about corroded steel. It will work out the friction differently. But let's assume this is a fairly new building and we're going to use new steel. So if we push the compute there, it would tell you 14 cubes an hour through an internal diameter pipe of 44 millimeters over a length of 65 meters through new steel grade material would generate a total friction loss of 14.2 meters. So that's the number we're going to put in there, 14.26 meters. All right, and voila, there's your entire duty point at peak. All right, this is peak demand. Your pressure requirement on your pump selection would have to be 67 meters, and your flow rate would have to be 14 cubic meters an hour. All right. Now, you can use this Excel spreadsheet exclusively just to use it as a calculator. I've taken it a step further, and I've actually created a layout of this document to give me my actual quote presentation to my client. And the reason I do that is so that there's no confusion as to what amenities we are talking about here. So when the client sees the quote and he goes through this list and he says, but hang on a second, I've actually got 4 washing machines on the premises. I'd know that I'd have to then upgrade this quote and change those numbers. And he knows exactly what the duty point is that we're doing the selection. So there's no disputing what's happening here. And when I obviously go back to the quote, in 3 years' time, the site's got maybe a bit of an issue and there's a dispute that the pump is too small or too big or whatever the case is, I have the reference on the original quote to see, well, this is why we did the selection the way we did, because these are the amenities we're talking about, right? You might just find that in 3 years' time, you don't know, and you might not remember. They've added another canteen on the building, or they've now incorporated a water fountain system or a fish pond or whatever the case is, and that amenity or requirement of water was never put in the initial quote. At least you have something to back up your original selection, and you can say, but there's now a new device on site there that we never had in the past. No wonder the pump's not working. So just keep those things in mind. So as I said, this thing would have my logo here, it would have my company details, telephone numbers, addresses, and everything else on there. And I would then go into the document and I would say the reference here is Mr. Customer number 1, whatever my references are. His name, the customer itself is the US government. The project reference is the NASA building. And now we'll start putting the pricing together. And this is how it would work. So on the pump section here in the middle here, I would put here that we are talking about 2 by Pentax model U5S 200S 5 2.3 2.2 kilowatt 230 volt pumps, and their collective price when I've done the calculation on the 2 pumps itself might be 12,900 Rand or dollars or whatever the case is. The switchgear we're going to put in here is a twin pump set, so it's a twin 2.2 kilowatt IP65 VSD panel, and the price on that thing would be 18,456 Rand for argument's sake. And the pipes and fittings, yeah, I would specify that I'm using suction and delivery manifolds as part of my supply. Manifolds complete with valves, and that collectively is 5,400 Rand. And the assembly, I'm using assembly accessories complete with wiring, and let's say the price there would be 2,450 Rand. And I'm not doing the physical installation on site, their own plumber will do that, so I'm not going to put a figure in there, and it would then give you a total excluding VAT. Simple way to do it, you can put whatever detail you want in here, and obviously you can change the cells here to actually list your currency with its own symbol. I took it out on this raw document, obviously, because you guys are from different countries, anybody that chooses to use this. And that's basically what it would look like. So just to give an idea, there, Mr. Customer, is your quote, and he then gives you an order, hopefully. So hoping that this is pretty useful information. Now, you might ask, how did I determine why I'm using two pumps, for argument's sake? Well, it would not be sensible on a commercial park or an office complex to go and put one pump in to produce all the water. Let's assume you had a pump failure. You then got no water on site, and you'd have to rely on the council pressure. Now, in areas where the council pressure is permanently low or too low for the buildings, especially buildings with flush masters, it would not be sensible to only have one pump. One pump fails, you've got no water. So what we would do is we would divide that duty point by 2. So instead of selecting a 14 cube one pump, we would select 2 pumps to do between 7 and 8 cubes each. But they will always do 66 or 67 meters total dynamic head on the pump curve. So the selection here would be 2 pumps doing 7 or 8 cubes each at 67 meters. That is the pump selection. And then we build a normal twin booster set, and I'll make a video that you can follow up at some point, probably in the next week or so. I'll show you how we put these twin pump sets together and why we use VSDs to do this. But if you're looking to just understand how to do multiple outlet duty point calculations, which is what this document is designed for, this is a very simple tool. And I will add that a certain amount of conservativeness and safety factors and everything have been put into these numbers here to give you a proper answer. I can assure you I've been using this calculator for the best part of 12 years. Never had a failed system where the pump selection was incorrect. The pumps might have failed for whatever reason due to their quality. Some pumps that we were free issued for clients to use. But I can assure you that the duty point itself, the calculation for the duty point, is very, very useful and very accurate. So I hope that works for you guys. And like I say, at the bottom of in the description, I'll put my email address. Email me, feel free. I'll gladly send you this calculator, and you can use it unrestricted. Thank you.